Yeah, welcome everyone to Map to Treasure. Emily Eiff will be presenting. She's been at ASU about 5 years and currently working as a senior data analyst with EdPlus.
Yep. Thank you much. So good morning, everyone. A quick thank you to Grant and Walter for serving as my room and Zoom hosts. I really appreciate that. Take a little pressure off of me in getting this presentation put together and running. If you have questions as I'm going through this, would you please post them in the chat, and Walter can let me know, or we can take care of those at the end when we hit the Q&A period. So otherwise, I guess let's get started. Today I'm going to discuss how the EdPlus data analysis team has been managing our database table documentation and standards, and then I'm also going to cover our database design, our dashboard design standards that we put together. So data is one of our greatest assets, but finding the data you want can seem like a treasure hunt. It's possible that you can stumble onto and through troves of hidden data, but discovering the buried treasure in the form of knowledge and insights is much easier if you have a map to show you what the data looks like and where it lives. So data maps can exist in a variety of formats. But all of them are essentially documentation. A key fact to remember, regardless of format, is that these are living documents. The one constant in technology is change. Definitions, connections, tools, usage, environments, all can and likely will change. To be usable and useful, documentation must be regularly reviewed, updated, and generally maintained to reflect those changes. There are a variety of reasons for creating documentation and standards, and a number of benefits and considerations to doing so. These can include consistency. So standard formats and naming conventions flatten the learning curve for your users. Clarity. When documentation is clear and thorough, there are hopefully fewer questions and incorrect or misinterpreted results. Usability. Having documentation is fabulous, but if it's not easy to find, easy to use, and easy to search, it's practically worthless. Accessibility. If documentation is hard to access, it won't be used, and if it's difficult to maintain, it won't be kept up to date. Current state. It's helpful to know what your environment currently looks like and where it's headed. Change tracking. So having a place to note in process and future changes allows for better coordination and communication. Planning, the ability to manage upgrades and changes with limited user impact while not missing key project deadlines. And finally, dependencies. Fewer surprises in the form of broken reports or incorrectly reported data caused by missed or forgotten relationships between changed objects leads to improved reliability and user trust. So there's also a variety of sources you can use to create and maintain documentation. These are some of the tools and applications that we, the data analysis team, are using to support our various aspects of documentation and standards. Some of the tools and functions were not things we started with. We added after we started our documentation journey because we discovered we had additional needs. But our key considerations were always the accessibility, the features, and the functionality of the tools we were choosing to use. So as it went, we were out there designing some data warehouse tables, and then we started designing some Aurora Postgres tables in the user databases, and we kind of noticed we really needed to document those objects. Initially, we started with the Google Sheet workbook to store metadata we decided to collect and maintain. We chose Sheets for its organization and layout, but ultimately ended up linking multiple workbooks using a variety of Sheets functions to accommodate the size of the data we were trying to maintain. Someday we hope that we will be able to house a good portion of this in Calibra, but until then, we've organized our table data into categorical workbooks based on the table definition type. So for example, dimensional tables, summary tables, log tables, or specific data sources like Salesforce, edX, or corporate partners are each in their own separate workbook. We have a master list of production tables, as well as the individual category workbooks. And those have complete lists of tables in any build status. Documents also have naming standards, column definitions, and templates, along with the specific table and column definition details. So this is what our master production table list looks like. Interesting to note, this tab is entirely populated by pulling data from the related category works, uses, and filtering based on a status field to only pull in production objects. So this is pretty much self-maintained as long as somebody doesn't add something to the formula, which happens occasionally. Another tab in master work is our list of related workbooks. So this is all of the various categorical workbooks that this tab pulls from to find the production ones. And you'll note here, line 11 has the dimensional tables workbook. Got that highlighted there. And that looks like this. So within these categorical workbooks, the first tab of each one is essentially a list of all the tables in that category, regardless of status. So tables that are already scheduled in production, things that are in our test and sandbox environment, tables that are in the middle of the build process, and we even list out future plan tables, which sometimes is a potential name and maybe a list of possible columns. Sometimes it's just a name. It's like, eventually we think we'll need this. So we document them here. And then also it includes all the table level metadata. I don't have it on this screenshot, but essentially across the bottom, the workbook also has tabs, and each tab contains the column level details for a specific table. So let's dive in. The type of data we're storing about tables and columns. For tables, we're including name, object type, description, a code-based location, which is either usually a raw SQL script, or a lot of our tables now are Alteryx workflows. So where does that live? A list of key and non-key fields, the current build status and locations, any associated tickets. We're using Jira for tracking purposes and workload. The refresh schedule, so how often is that data updated? Any dependencies on other tables that might cause some issues. An indicator of whether there's any future column additions or changes to that table, anything planned in the future. And then finally, notes on sources, filters, or other population limiting criteria. For example, we have registration tables that intentionally exclude orientation courses, so we make sure that that's noted. We have other tables that only have last 3 years worth of data for space and processing purposes. So that's the tables. And then on the column side, we record the name, synonyms, because we seem to like to name things differently than the original sources. And we tend to change our own names over time frequently. So we try to keep track of some of that. The data type and size, short and long descriptions, which we also hope eventually might be able to be stored in the database itself in the comments for the table creations. List of permissible or sample values. So for a column that has a limited number of possible values, we'll list all of those. Ones that are more random, a date or something that you're not going to list all possible values, will at least include a sample of values that are out there. So minimally you get the format that data lives in. Also keep track of any definition, coding, source, or usage notes about the column. A nullability indicator, so whether the column can contain nulls or not. Again, any planned coding logic changes that we're aware of, and whether the current usage meets a standard definition. So we actually standardized our column definitions across tables. I'll go through that in a little bit, but there's an indicator whether that's a standard definition or not. Early in our process, we also decided that as we were designing these tables and starting to document them, we decided that the column and table names themselves needed some standardization. So we documented a corresponding list of terms and abbreviations, and that lives in our master workbook and looks like this. So these are component pieces, and we use these to build up table and column names. This list specifically indicates our preferred terminology, as well as which terms we abbreviate and how we abbreviate those. The note at the bottom there about granularity and distinguishing details is sort of our guideline for how to create a unique and informative, if not usually slightly very long table names. As I noted, we've also decided to standardize our column definitions. That ensures consistent use across multiple tables. So in the math book of standard columns, along with all of their corresponding metadata, the details I discussed here are what we're recording about our standard column definitions. Yeah, you can kind of just see what those look like. And then finally, this is a sample table definition tab. This case, this is EP class dim, our class dimension table. So if you remember when we looked at the dimensional table workbook back here on slide 9, this is the dimensional tables category workbook. Line 14 here shows the EP class dim table, which is its own tab across the bottom, and that tab looks like this. And so yeah, this contains all of the column level details for that table definition. One thing I wanted to note here, column E header is standard. So this is the indicator as to whether this is a standard column definition or not. As used in this table, is that a standard column definition? And so if this field is Y, there is a formula that sits in column F, which is actually at the top here, not that you can read it in the tiny print on this slide, but there's a complex formula that uses import ranges and matching and some other things to look up the column name in column C on the standard column definitions tab, and assuming it finds a match, it will populate columns F through P with the same data that's in that standard column definition. So that keeps everything consistent across tables. And we know that assuming that this is a standard column definition, it's not defined one way in one table tab and a slightly different way in the next table tab. And so that keeps things consistent. On the chance that we have a non-standard column definition, something that's a one-off, that's really not going to be used in another table, or the definition as used in this table is slightly different than how it's normally used, we would mark that as a non-standard, mark that as a no in that column E, and then manually enter the values associated with that across the rest of the columns in this table. So we went through and defined a bunch of these tables, bunch of different views that we'd created, put them all in our Google Sheets. Then we started looking at things going, be really nice to understand how all of these objects relate to one another, how they're dependent on one another, because we found we're building tables and views on top of each other. So we took our next step and added a lucid chart. This is very much still a work in progress. This is the actual lucid chart, and we have an endless canvas on this thing, so it just goes on for pages if it needs to. This entire white column on the right side are all tables that need to be integrated into the diagram. So that'll tell you how far we've got to go in this process, but it's a start. And it's already proven very useful. We use this to help us organize our projects, plan our workloads, and set some rough timelines. We're hoping someday maybe some of this can be stored in Calibra, but we're not quite sure how that would work and if we'd be able to get it back out in a way that's as nicely visual as we would like it to be. So Some of the features and functions that are kind of built into lucidchart or native with lucidchart, we're using the shapes and colors, all the variety that's available there to help delineate things. So shapes define the data source and the object type. So at a quick glance, after you've looked at the legend, which this is at the top of the sheet, you can quickly go, oh, that's a table, that's a view, that's coming from the data warehouse. This is a Salesforce table, that's a Google Sheet or some other sort of a flat file as a data source. And then the colors, the shading is used to indicate where the object currently lives and what state it's in. So if we haven't defined the table, it's in pale purple. If we've defined it, but it hasn't been built, it's pink. If it's in our sandbox, it's yellow or blue, depending on whether it's been QA'd and if it's scheduled or not scheduled, green for production. And then even to the point of, we'll color the name in red text if we know that it's something that's going to change. Eventually, we have planned column additions, column deletions, logic changes to the code. That'll get coded red. So you might want to double check the definition in the documentation in case you're using something that's planned to change eventually. And then finally, we found we have some tables that we've built that we're building better versions of or slightly different versions of. So those are getting replaced, and we're denoting those by using the strike through text formatting on those. So this is the essential layout. I've zoomed in on the top portion to kind of highlight some of these. So the horizontal swim lanes along the left side are used to group our table objects together. So these are all of our leads tables. These are application level tables. This group is currently student level. So that we've got plan level and graduation and some general stuff. These might get broken out into separate categories eventually, but for now, there's few enough that they can stay in their own. This is a miscellaneous, I'm not quite sure what those are or where they live. There's probably 10 or 12 categories in the whole sheet right now. And as I said, we'll add and adjust those as we need to. The vertical swim lanes, so just left to right, are pretty much just there to show the gradual growth and dependency of objects. So things on the left are sources for the things as you move to the right for the most part. This left column that's fairly empty, the intention is to put the original source location for our data. So data warehouse tables for the most part in our case, and we haven't filled all of that out yet, but we're working on it. Another feature that's not shown in this visual is the layers function. We're using that to help group objects by source and statuses. And the way the layers work, when you select a layer title or click on an object that's in a given layer, other layers, objects in other layers will sort of fade into the background. They get more transparent, and your chosen layer, it remains bold and in the forefront. So that can benefit because I've got a layer for just views. So this object here is a view. There are several others lower on the table, but if you click that layer, all of the views would pop out. You can see which ones are views, and the tables and other objects will sort of disappear into the background. We also included this whole column to the right is our planned or existing dashboards, and that helps us see where the data is being used endpoint. It's actually being surfaced to users at that point. And having those dependencies visualized helps us know, if we're making a table change or adding a new table in, what things might we need to check aren't going to break because of changes we're making. And it also helps us know, as we get ready to build out new dashboards, do we have all of the objects built that are going to be needed for that dashboard build? So speaking of planning, as a team, we're still somewhat new to the concept of release cycles and planning and all that, but we're learning to use these tools in our documentation all in concert to help us manage changes to our environment. And that kind of process kind of looks like as new tables or table changes are identified, we'll denote in our table documentation in the Google Sheets. We have some ways to, this is a table that needs to be added. This is a column change. And then we'll create a JIRA ticket to denote that workload and make sure that we add relevant tags for epics, components, and versions into that ticket. The ticket gets assigned out to a team member who will then create or update the code, whether that's raw SQL and Alteryx workflow, some combination of the two. And they will also update the corresponding documentation. Once that's complete, the builder will review the code and documentation with the team during a weekly development meeting, and then ideally go through a quality assurance review one-on-one with another teammate. Any recommendations or concerns that came out of the reviews get addressed, and everything gets re-reviewed and kind of signed off on. And then quarterly, using those JIRA tickets and some of the epics components versioning as our source, we will freeze changes in our environment, figure out what changes are pending, put together a script, communicate that plan out through some Slack channels and in team meetings, and then roll out those pending changes. So you're thinking, okay, so you've got all these tables, you've got this process you're managing, you've got everything well documented. What do you do with all these things? And what we do as a team is build standardized dashboards. As more of our team began to develop more dashboards, we decided that a common look and feel would be beneficial. So in the hopes of reducing user confusion and frustration caused by subtle design differences, just personal quirks when you're putting something together, we developed some standards, basing those on a combination of industry recommendations for visualizations and the things we were finding our users wanted, needed, or preferred. Our decisions often revolve around simplifying visualizations in a manner to present more data more cleanly in the limited real estate available on essentially a single screen, because one of the big things we found is they don't like to have to scroll if they don't have to. So this is an example of a dashboard that we designed before we set our standards. It follows general good visualization practices. The data is well labeled. The titles are easy to read and understand. There's an intended message and story that are being conveyed. But what we found is that this style dashboard can be so much better with a little tweaking. So our visualization standards focus on five primary areas: use of color, fonts, headings and titles, user interface and user experience aspects like layout, chart and table types, interactions with filters, parameters, and toggles, and then lastly, terminology and definitions. And we have a very strong admonition when applying our standards that they be applied when appropriate and when possible, because we realize hard rules don't work for every situation or tool. For ourselves and our dashboards, we've chosen to use primarily white backgrounds. We will add in light gray if we need to, if we place charts next to each other and it's hard to tell where one starts and the next one ends. We can use some light gray background to help differentiate those. When we use data tables, we add alternating rows of white and gray so the user looking at the table can see, what's a row and not kind of zigzag across them if they're looking at data. We prefer ASU colors per the brand guide when we are using color. This is the brand guide palette for ASU colors. But we will use corporate and department colors when they are appropriate. And ultimately, we found the sparse use of color makes a greater impact when you're telling a story, and consistent use of color is important for making sure your users don't become confused. So here's an example. In this case, we used Starbucks Green because this is Starbucks College Achievement Program data. We had intentionally limit its use to highlight a specific value, in this case, enrollments. And we chose the enrollments because we were trying to draw attention to the goal of the program. Starbucks wanted to make sure that their partners could get college degrees. So while it's important that they start applications, submit applications, complete them, and ultimately get admitted, it's the enrollments that really put them on the track to actually starting and finishing a degree. So we've highlighted enrollments in this case. This dashboard is an example of using consistent color. This tracks Salesforce leads by week and compares the results across years. So we used maroon, gold, and gray to represent the 3 most recent years in the top chart here. And the lower charts, which break out leads by college, so it's at the individual college levels, we made it a point to make sure that 2020 was always maroon, 2019 is always gold, and 2018 is always gray. So a user scrolling through the individual college charts doesn't have to stop and scrutinize each chart and go, okay, I've looked at the top, I want to compare the red 2020 to the gold 2019, and then have to stop and recalculate every time they go down to see what colors they need to pay attention to. Per the brand guide, ASU does have an official font. Thankfully, they also have an approved system font of Arial that's much more readily available in tools and much easier to use. So we've chosen Arial 9-point black as our standard for most of the text on our dashboards. That includes chart axes, table data, filter and parameter titles, and footer definitions and notes. Tooltips we bump up to a 10-point just for readability. Section headings in the footers and filter and parameter titles we bold. Filter titles we change to maroon to differentiate between filters, which limit how much data is visible on screen, and parameters, which change the type of data being viewed. We leave those in black. When using numbers, which is a common thing, we prefer that they be formatted with monetary or percent symbols if they represent such. And we add commas to delineate thousands, millions, etc., just for readability. The other thing we found with readability, limiting decimal places to the least number needed is actually beneficial. So you'll see in this chart, we're only using 1 decimal place. The top of page header, our preferences are Arial 18-point bold black text, left justified on an ASU gold background. Our preference is to include what's being measured, filtered, or segmented as part of the title. That's just to make it clear and obvious what you're looking at. The lower report and chart headers, we do Arial 12-point bold black, left justified on light to medium gray. And our title naming, a starting point is something of the effect of measure by dimension, segment, and other dimension or time frame. That's just kind of a guess to go with if you've got nothing, if you know exactly what you're measuring, but that kind of keeps things clear and consistent. And we include the filter parameter names or their actual chosen values in the titles whenever we possibly can. And we make it a point to bold those so that they stand out. So you kind of know to look for them elsewhere in the dashboard. For space utilization and readability, we've limited our visible parameters to a maximum of 5 or 6 primary values at the top of the dashboard. When we have others, which is common, we'll hide those behind a filter icon. Determining what's a primary filter parameter is based on its impact and importance to the dashboard itself, or if there's a default value set to limit the data being presented initially. The details about the primary filters and parameters we place behind information icons near the filter name. So in this case, this I up here in the corner, if you clicked on that, would pop up this little definition box. If a filter or parameter is applicable to a specific chart or table, we will move that from the top of the page to either into or just below the subheader for that chart or table. That way you recognize it's relevant to only that subsection. Definitions for the secondary filters and parameters, as I noted, get put behind a filter icon. And we just put those in with the selection options there. We have found that the use of the filter icon requires a limited initial user training, but ultimately it produces a cleaner and less confusing dashboard. So it's our direction to go that way. The other thing we do with our filters is we'll only show relevant filters. So once you've chosen a particular filter, once you've chosen a value for a particular filter or parameter, the values available for others are limited to the corresponding data. So for instance, if you choose a college, here only the programs within that college would then be shown in the program dropdown. And to avoid confusion, we do add a tooltip or a note in our footnotes section, something to the effect of, is there a value missing in the filter? Try changing or clearing other filters, so that if something's not obvious why it's missing, the user can kind of find that on their own. With so many chart types available out there in the tools that we're using, determining the most appropriate visualization is a challenge. We have some general rules that we use, starting points when we're choosing and formatting charts. Bar charts we prefer for comparing categorical data, and we set the sort order depending on the type of category, whether it's ordinal or nominal. We prefer line charts for continuous time data, column charts for discrete data across time sections. When we're displaying a data table that includes a time component, we put that on the columns, so you would scroll across time, whether that be up or down. You're scrolling across, whether that's time progressing forward from historical or current to historical. And per a variety of industry standards and articles on why pie charts are bad, that's a fun thing to search for on Google. We avoid using them except in very limited situations. The one we will always allow is to indicate how much pie has actually been eaten. And again, these are very much starting guidelines, not hard rules. We do use a variety of chart types and formatting configurations as warranted by the data and the story we're trying to tell. As I noted earlier, we found users prefer to see everything or as much as they can all at once without having to scroll around dashboards too much. So to conserve space and provide additional details, we create what we consider interactive toggles that will switch between various views. So in a specific area of the dashboard, the same data can be displayed in like a chart form or a detailed table view without using up more real estate on that page. In this example, the same math, enrollment, and grade distributions for non-passing grades is displayed one of four ways, either total by year, total by term, course by year, or course by term. And that's all controlled by the user choosing various combinations of this toggle. Another option we use, not just the radio button toggles, we'll actually use a pick list drop down. So this is another dashboard. This one gives the viewer 5 different aggregations options for the exact same data table. So the same set of data is displayed in a variety of breakouts depending on their choice. But that saves space and still provides the user lots of options. These are some suggestions just to keep viewers, make things easier for viewers while keeping our looks simplified and streamlined. So consistent use of terms and names throughout the page or the tab or across the entire database when it's possible. We like to include some form of contact info for questions. We use an EdPlus at ASU logo on somewhere on our dashboards for that purpose. Provide basic data source details, and we'll also include a refresh timestamp that's pulled as part of the data query. That helps users to know how current the data they're looking at is, or if maybe they're looking at an obsolete dashboard that hasn't been updated in 3 years. And And it also helps us to realize if things aren't updating as scheduled or expected. You know, it's a good check that all the things are happening as expected, kind of behind the scenes, and your refreshes are occurring as planned. To keep our charts clean, we use data labels when possible, add simple legends only when necessary. We remove grid lines that indicate numeric levels if the labels are visible, because they're really not needed anymore. We'll only add title or axis labels if those details can't be ascertained from the surrounding headings and other labeling. For data tables, bold the row and column headers just to help them stand out. Again, as I noted before, alternate those row colors. So a white row, a gray row, a white row, a gray row. So if you're reading across, you're looking at a specific value and you want to look at the one in the 7th column to the right, you don't inadvertently shuffle down a row when you go to read that. And we will add totals to our tables where they're logical, with the caveat that if there's any reason that the values displayed don't total up to the total, that's denoted somewhere in a footnote. And that can happen because you've got your data's broken out into various categories, and students can be, for instance, a student could be in multiple categories, but we want the total, only count them once. It's a distinct count of students. Lastly, terminology. On-page details like definitions and tooltips, we find add depth to our dashboards and make them more user-friendly. So in addition to the filter and parameter info and the data source details in the footer I've mentioned, we try to include usage notes and field definitions in our footers. So this is an example of some usage notes. This is an example of detailed definitions. There's some sources. This is one of our logos that we include for contact purposes. And some general terminology recommendations. Don't assume the new user has prior knowledge about the data in any way, shape, or form, but you also have to balance that with not writing an actual manual on screen on your dashboard. Ideally, we have someone review have someone else in your team review your definitions and descriptions. That's a proofreading, a clarity, and an accuracy fact. Just make sure things aren't confusing. Somebody else looking at it might find something confusing that made perfect sense to you, especially when you're deep in the data and completely understand it and they don't know anything about it. Avoid using the word to define it, or if you have to, at least restate it slightly so you're not confusing your users. And please, any acronyms, spell them out at least once somewhere on the page. The last thing that we like to add as sort of an additional definitional thing or bonus data are tooltips. A lot of the tools you can set tooltips that appear when you hover over the data. And we'll often add those to chart and table data. So details like percent of total, for instance, here, this is a grade distribution detail. We've provided the data that the users would want, but if you hover over one of these values, you get what percent. So in this case, the C's were little more than 10% of the total grades. Another one I found on a different chart, we had a list of courses, course completion count, so by course and the number of students that completed that course. And if you hovered, you would get a tooltip pop-up that gave you the average grade received in that course. So it's just another depth of detail if you have that available in your data that you can provide to your users that might not be easily displayable on your current visualization chosen. So quick recap, that's all 5 areas. So here's the kinds of things that we tend to include on a standard dashboard. So headers with descriptive titles, including parameter names and chosen values, as well as an update date on the page. Interactive parameters and filters, primarily the primary ones at the top of the page, any others behind the filter icon, all of them having definitions nearby. Visualization toggles to add depth and more data with less scrolling, a footer with any additional notes and definitions, and a logo or some form of contact info. So hopefully you remember this before standards dashboard. After applying our standards, this previously somewhat static, I think you could actually choose the, I don't know if calendar year was set, and you might have been able to choose the date on this, but this was a requests for information, so RFIs to actual admitted students, people who requested an RFI, and how many of those actually followed through and became admitted, a year-to-date calculation for that. And this ultimately became this very interactive funnel dashboard. So essentially the same data can now be viewed in a variety of ways by changing the filters and parameters available. But those same details are still available. And this version provides more data in a cleaner, more consistent format with user interactivity and additional details, all while adhering to some simple standards. So hopefully you've seen something this morning in what the EdPlus data team is doing that can help you on your quest to slay data monsters by improving your own documentation and standards. So it's time to go out and draw up your own maps and go find some buried data treasure. Any questions or comments? Walter wants to unmute and everybody can talk, or
yeah, everybody, if you have a question, please feel free to speak up. Everybody should be able to unmute themselves, or you can put it in chat if you want, and I'll relay it.
I'd really like you to post that lucid chart in the Calibra channel and ask them how to capture it.
Can do.
I love how you all are doing this standardization, because really that's key. You have, for anything, you have to have a standard, otherwise it gets confusing from view to view or chart to chart or dashboard to dashboard. So thumbs up for me.
That's what we were hearing from our end users was, you know, oh, I love this dashboard that so-and-so created, and you just created this new one for me, but can you add those other things over there that were on that one? It's like, okay, let's put some standards and let's all have them at least look somewhat similar and have the same components to them. So, yeah, if anybody has, go ahead.
I really love the documentation piece too in the Google Sheets. I'm curious how that gets most used. Is it for discovery, or is it really to verify or look up logic?
Little bit of everything, because within our team, there's a couple of us who primarily end up defining and creating tables, and then the rest of the team, the people building the dashboards, the people doing modeling, need to use those. And you know, you can review things in meetings once or twice, but until you actually need to dig in and start using the data, you don't really pay attention. You know, so it's both a lookup, it is a discovery. As I said, a lot of it's also tracking. We'll keep track of, oh yeah, we found we need to update the logic in this column, so we'll note that in there. Yeah, the variety of uses and reasons.
That's cool. So it really fuels your collaboration.
Yes, very much so. Yep.
Excellent.
We have a question in chat from Paul Alvarado. Was the lucid chart made with the out-of-the-box features, or was there a paid fee for any of it?
That was originally started when the free accounts were still working. And with all of the issues that came up with lucid chart recently, ASU has gone, or EdPlus at least I know, has gone through some iterations to get licenses and accounts, and that one did get switched over to a license account. But I think that was basically done with what was free at one time. You might need a license to do it all now. I'm not sure what the restrictions are.
I don't think anything in that would violate the free tier restrictions, because that's based on number of tabs that you create, number of documents that you have on your account. The one thing it might have a problem with is there might be a limit to the number of items you can put on a page.
that after we started converting, because I wasn't using Lucid much, so I only had like 1 or 2 documents myself, so I was well under the 3. And once they changed the restrictions, I think I started getting errors that I couldn't do things with that one in particular, and I think it was a object count.
So you could do that as long as your data mark's small.
Yeah. Anybody else? Nope. And yeah, I just wanted to add, those Google Sheets are very interconnected. And if anybody else gets to a point where they need to do some of that, I unfortunately, through necessity, have become an expert at some very fancy Google Sheets interactivities and joins and formulas and things. So yeah, let me know. Or I can, kind of give you access to those. Maybe you can look around and see how everything's tied together. But yeah, there are some little tweaks and things, but yeah, Google Sheets can be very powerful if you get behind the scenes and sort of learn how to use their formulas and functions.
I need to put you on my speed dial then. I always have questions and constant Googlings to do nifty things, and I suspect you've already done them, judged on what you presented today, so well done.
I probably have, and to be honest, I did them all by Googling and playing around, so yeah.
At one point, Emily had basically built Salesforce in Google Sheets.
Yeah.
It was kind of...
That's impressive. Well done.
We had the very early CRM for our Starbucks partners and our early corporate partners was running off of Google Sheets I put together. Yeah. For about 3 years.
There are limitations to Google Sheets, just like there is lucidchart.
Yes. And I found several of them. Okay. Thanks, everybody. Have a great day.
Stop the recording. And yeah, excellent. Appreciate the presentation. Thanks.
Welcome.